Good morning, students. So, today's class I am going to start with the repetition of organic chemistry. So, the first chapter in organic chemistry is haloalkanes and haloarenes. I'll give some important questions and I'll explain only those questions. And you be prepared for that, which are very important for examination. So, those questions what I am telling is that is reduced syllabus also. Okay, which is removed from your syllabus. I will not give you here. Of course, in this nomenclature is there. But remember, in our organic chemistry, so I won't explain any nomenclature initially. So first I'll explain only the chemical reactions. So after completion of all the chapters like haloalkanes, haloarenes, alcohols, phenols, ethers, haldehydes, ketones, carboxylic acids, amines. After completion of all these three, at the simultaneously I will explain the nomenclature of each and every functional and their priority. Understood? So initially I won't explain nomenclature. I will explain only reaction. So this is for 1 mark nomenclature. Second one is classification. Of course, this is also I will explain later. This may be 1 or 2 marks. Possibility. Nomenclature and classification I will explain after completion of the repetition of each and every chapter. Okay? Next, third one is very important. From here, SN1 mechanism. 3 marks. Next, SN2 mechanism. Actually, this is also 3 marks question, but it will be asking like 2 plus 1. Okay, so consider this one is also 3 marks. And the fifth, Woods reaction. Woods fatigue reaction. Fatigue reaction. Finkelstein reaction. Swartz reaction. Sandmeyer's reaction. Halogenation. Sulfonation. Nitration. Friedel-Crafts. Alkylation. Friedel-Crafts. Acylation. Next, Lemson's synthesis. Okay, last one. Reaction or preparation of haloalkane from thionyl chloride. Okay. Marconi capsule. The last one is such a story. And isomers. Okay. So don't think in the only single chapter 20 questions are there. Of course, those are not very easy. The most important is this and this. These are exceptional. I wrote according to the priority order only. Understood? So most preferable is this is exceptional. Of course, this comes first in the chapter, so I write it in the first. Nomenclature is exceptional. Classification is also exceptional. They may ask, they may not ask. But from year to year, it is compulsory year. And these are exceptional. They may ask, they may not ask. But as I told you, so today, so your some chapters are reduced means the 5 marks, one question from polymer is completely removed. There may be a chance of asking one more 5 marks question in this chapter. As it is a big chapter and consists of so many questions, there may be a chance of raising another 5 marks question. Understood? That's why I will explain each and everything. So these are the important reactions and things we are going to so another one is the rate. Beta elimination. Of course, this beta elimination is also associated with Marconi capsule. If I explain that, then you will easily understand beta elimination reaction. Understood? So I'll go with the one by one. That is SN1 mechanism. Okay, so this SN1 mechanism is also asked. Explain the mechanism of reaction of tertiary butyl bromide with alcoholic KOH, aqueous KOH. Understood? Then as reaction of tertiary butyl bromide with aqueous KOH. So listen students, why we are using aqueous KOH here, why not alcoholic, I will explain later. So that is also important for 1 month. What is the product formula when we are going to use aqueous KOH, when we are going to use alcoholic KOH. Understood? Later I will say. So listen, first one, the main reaction you have to write. So what is the main reaction? Tertiary butyl bromide. This is the tertiary means to the same carbon atom, 3 carbon atoms are attached. Bromide means Br. Here it is CH3, CH3, CH3. Reacts with what? KOH. So SN1 means what? It is a nucleophilic substitution reaction. Which one is the nucleophile here? Br minus. Here OH minus. Nucleophile is going to substitute, means Br is going to be replaced by this OH. Yes, N1 means nucleophilic substitution unimolecular, means it is a single order, first order reaction. SN1. So what happens here? The product formed is tertiary butyl alcohol. This is OH plus Kbr. Okay, so it is what? Tertiary butyl bromide. This is tertiary butyl alcohol. So this is taking place in two steps. Step 1 and step 2. So I'll write the mechanism. Listen, this is the correct way of writing the mechanism. Initially, the main reaction followed by the mechanism. Understood? So no need to explain this reaction. Like tertiary butyl bromide reacts with aqueous KOH forms tertiary butyl alcohol. No need to write because they are asking mechanism, but they need the main reaction. Then you'll get the complete. So let's start with the mechanism. Okay, so in that mechanism, step 1. So step 1 is formation of carbocation. So I have to write this here. Formation of carbocation. Okay, so students, here what happens? This tertiary butyl bromide, and right here tertiary butyl bromide, okay, loses or undergoes dissociation to form tertiary carbocation. This is the main. So listen here. This is the reagent. Tertiary butyl bromide. CH3, CH3, CH3. So you have to write the formation of carbocation. Means this must be dissociated as what? Br minus. So you have to represent the arrow mark like this. The representing arrow mark is also important. Means Br is going to detach from this tertiary butyl bromide along with the electron of carbon. This arrow mark indicates this Br is dissociated along with the electron of carbon. So here it is CH3, CH3, CH3 plus Br minus. Okay, so this one is the slow step. So 1 in the reaction mechanism, 2 steps is there. You know, in the chemical kinetics I already explained. 1 which is the slowest step, that is the rate determining step. So this is the slow step. We can easily determine its rate, means time taken for the reaction. And the next one is step 2, attack of nucleotide. Nucleo means nucleus, philic means phile means philic, nucleus loving, which are negative in charge. It is positive. Nucleus is, as I told you, that is positive in charge. So positive charge loving species are called as nucleophiles. Electrophiles means electron loving, means they are positive in charge. Okay, so attack of nucleophile from KOH, which is the nucleophile here, OH. So attack of nucleophile is what? So listen, OH minus ion or hydroxyl ion we take. Hydroxyl ion from aqueous KOH is attached to carbocation to form tertiary butyl alcohol. This is the second step. Okay, so take here, this is tertiary carbocation. Plus OH minus. Okay, so students here, this OH minus going to attach here, then they form CH3, 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 OH. Okay, so this is tertiary butyl alcohol. This one is tertiary carbocation. Writing the name is also important. Tertiary butyl bromide. This is tertiary carbocation. Why? If you do any mistake in the explanation, then if you write the name here, then you will get the full marks. Understood? This is SN1 mechanism. So students remember this SN1 mechanism. Of course, I wrote this type of what is that product here. Means here from which side Br is detached to the same side OH is going to attach. So retention of configuration takes place here. In SN1 mechanism, retention of configuration takes place. But remember, so listen, this one is the fastest step. This is the slowest step. This is the fastest step. Means the rate of the entire mechanism is dependent upon what? This first step. Means how much carbocations are formed, that much tertiary butyl alcohol will form. Understand? Listen here. So tertiary butyl bromide is in 1 mole. So this is in 5 mole. This one is in 1 mole. KOH is in 5 mole. Even though the product formula is, the tertiary butyl alcohol formula is how much? 1 mole only. If it is completely dissociated. Assume only 5 mole or 0.5 mole of carbocation is formed. Then 0.5 mole of tertiary butyl alcohol will form. Means the entire mechanism is depends upon what? The formation of carbocation. That is the first step. Hence it is a first order reaction. Understood? So if you write this much, you will get 3 marks. Then what are the things you have to remember in this? Listen, for NEET I am telling. Initially it is with the sp3 hybridized. So your 2, 4, 6, 8 electron is there. 8 electron system, sp3 hybridization is there, tetravalent. Here 1, 2, 3. Okay, if 2, 4, 6 electrons are there. One bond is less, and of course there is no electron. So 6 electron system means it is a carbocation. It is sp2 hybridized. If it is sp2 hybridized, then it is which shape? Trigonal planar. Means like triangle shape. This one is tetrahedral shape. This is triangle shape. Okay. So when this is in a triangle shape, planar shape, there may be a chance of attack of OH from this side or this side. But I wrote here, this is enough for you. Possibilities I am telling you. So this may be, means attack of OH maybe takes place from this side or this side. So in the SN1 mechanism, there is a possibility of formation of 2 types of mixtures. One is this side, another is this side. One product is as the original reactant, another one is opposite of that. Okay, and those are, if I write here, I hope you can see, if I wrote the mirror image, it will be like OH, C, CH3, CH3, C. These two are what? Mirror images. So in the SN1 mechanism, there is a possibility of formation of this type of mixtures that is called as racemic mixture. The last, in the isomerism, last I told you, remember? Isomerism also I write in the question mark. So sorry, questions what I given. So that is racemic mixture. Mixture of 2 non-superimposable mirror images. A mixture of enantiomers. These two are called as what? Enantiomers. So later in the isomerism I will explain. Just remember this. SN1 mechanism forms 2 types of mixture called as racemic mixture. Okay. So but in this the majority is This is 51%, this is 49%, only that much. So this is slightly excess means we will consider this one as the major product. Understood? Okay, so you just write this much for the SN mechanism, then you will get complete 3 marks. Next, so here listen, as I told you, here we are using aqueous KOH, not alcoholic. So many times we used to say alcoholic KOH also. What happens when we use alcoholic KOH? So I'll explain. Remember students, so in tertiary butyl bromide, why the initially formation of carbocation takes place, why simultaneously making of bond, breaking of bond cannot take place. So listen, CH3 means, as I told you, here Br is there. Correct? These CH3 groups are what? Electron releasing groups. Understood? They are what? Electron releasing groups. These releases electrons to this carbon. This is also releases electron towards this. This one is also releases electron towards this carbon. So at this carbon, electron density increases. When the electron density increases, it prefers removal of electron rather than gain of electron. That's why it easily dissociates. Why the carbocation formation takes place initially followed by the attack of nucleophile means because of the presence of the 3 electron releasing groups. This is what very important for NEET. Question, the basic question they often use, why the carbocation? You may know why the tertiary carbocations are more stable. You know, tertiary is greater than secondary, greater than primary. This is the carbocation, what is stability order. Why? Because of the presence of the electron releasing groups. Understood? So these differs easily formation of carbocation. Understood? So here, if we use alcoholic KOH and aqueous KOH, what is the problem? That is, sorry, what is the product formula? That is also important for 1 mark. So listen here. Aqueous KOH, we know this is the product. What is that? CH3, 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 OH, tertiary butyl alcohol. So instead of that, if we take alcoholic KOH, so I'll write the reaction here. Okay. Plus KOH. So then what happens? So students, when we are going to use alcoholic KOH, after the formation of this, okay, so I write here CH3, CCH3, CH3, OH plus KBr. Okay, so even though formation of this, when alcoholic KOH is used, alcohol is more reactive than water. Means alcohol requires water. It is more affinity towards water. So then what happens when we use alcoholic KOH, the reaction cannot be stopped here. So then again dehydration takes place. Here OH is removed or any one of the carbon atom gives its hydrogen. So then it forms CH3, C, CH2, double bond, CH3. So this is the reaction going to form when we use alcoholic KOH. So alcoholic KOH if we use means, so at the same time simultaneously dehydration as well as dehalogenation takes place. Dehydrohalogenation. Hydrogen is also removed, halogen is also removed. At the same time, water molecule is also removed. That is important for 1 mark. What is the product when alkyl halides reacts with aqueous KOH, that is alcohol. What is the products when alcohols reacts with alcoholic KOH? Sorry, alkyl halides reacts with alcoholic KOH. Alkenes are the products. Okay, important for 1 mark and 10 in the board examination also. Okay, so next we will go to SN2 mechanism. Okay, this is reaction of methyl bromide with aqueous KOH. So this is what SN2 mechanism. So students here, and write down the mechanism. Methyl bromide, that is CH3Br, reacts with KOH. It forms, what happens? CH3. What is the product formed here? CH3OH plus KBr. This is the main reaction. So this is methyl bromide, and this one is methanol. Sorry, don't write here methyl bromide because I tried use iupacname. This is bromomethane. Both are same. You may write methyl alcohol also. Methanol is the iupacname. Methyl alcohol is the common name. Methyl bromide is the common name. Bromomethane is the iupacname. Okay. So I will take mechanism. So students, this is a single step mechanism. It consists of only one step, even though it is a second order reaction. So why means, listen, initially this CH3Br is there. Here there is no extra CH3 group. It is already in a planar form. So how it is? I'll write like this. This is hydrogen with the dash dash. This one is Br. Okay, this is the structure. These two are, as I told you, planar or in a plane. This is towards the observer. This is away from the observer in a tetrahedral angle. Okay, so like how I show here. Listen, if this is the tetrahedral angle, okay, this is exactly a tetrahedral angle. So here these two are the planes. This red one is away from the observer and this one, green one, is towards the observer. If I am the observer, these two are the plane. Okay, this is away from the observer, this is towards the observer. This is in three-dimensional arrangement that we cannot be represented. So I represent it in a solid wedge as well as slash wedge. Okay, so here what happens simultaneously. So where Br is there, at the same time OH minus is going to attach from here, from the backbone. So then what happens here, carbon is here, hydrogen, hydrogen, hydrogen. Okay, so here at that time, same time, breaking of bond between Br takes place. Simultaneously, making of bond with OH minus takes place. So in the same state, breaking of the bond is also taking place. Formation of the new bond is also taking place. So this state is written in a square bracket called as transition state. Transition state, where the breaking and the making of the bond takes place simultaneously. Understood? So later, after the transition state, Br completely detaches and OH completely bonded. Okay? Then we form Here OH, here Br minus. So students, this Br minus combined with K plus forms KBr. Understood? This is the mechanism takes place. How can you explain? There is only one explanation is there. When methyl bromide reacts with OH, simultaneously the OH minus, the nucleophile going to attack this methyl bromide from the back side. So then what happens? They form a transition state where the making and breaking of bond takes place simultaneously. After some time, so this Br minus detaches and OH minus forms a bond with the forms a bond and forms the alcohol. Okay, this is transition state. This is methyl alcohol, bromide, are you right? Bromomethane. This is methyl alcohol, you may write methanol. Understood? This is SN2 mechanism. And listen here, the formation of this, as I told you in a transition state, both OH minus bond formation is also involved and Br minus bond detached is also involved. Means both the reaction, the complete SN1 reaction depends on both this methyl bromide as well as KOH. Because when the OH is attacking from the backward, then only bond breakage taking place here. Means it is completely depends on both the reactants. That's why the rate of reaction is a second order reaction. Understood? And the order of a second order reaction is, as I told you, this is a primary alkyl halide. So the reaction state is primary, secondary, and tertiary. Means SN1 mechanism is favors in tertiary, secondary, primary. That is the order. And SN2 mechanism is favors like primary, secondary, tertiary. Means if primary is there, that is SN2 mechanism only. If tertiary is there, that is SN1 mechanism. This secondary, it may be either SN1 or SN2 in between. Understood? So this is all about SN1 and SN2 mechanism. And of course, difference is also there. Difference between SN1 and SN2 mechanism. Am I right? Okay. Difference between SN1 and SN2 mechanism. Okay. So right here SN1, and it is SN2. So students, in SN1 mechanism, it is a unimolecular reaction. So this one is of course bimolecular reaction or mechanism unit. Okay. So SN1 mechanism consists of how many steps? Okay. It is two-step mechanism. And of course this one, single step mechanism. Okay, so order of carbocation is what? Tertiary greater than secondary greater than primary. Instead of that, you take stability order. Stability order of carbocation. Next. Here it is primary greater than secondary greater than tertiary. Next here, retention of configuration takes place. Here it is. retention of configuration takes place. Here, inversion. Inversion of configuration takes place. Remember students, and this one takes place in protic solvent. This one takes place in non-protic solvent. Understood? Okay, this is all the difference between SN1 and SN2 mechanism. Okay, so the next one is Wood's reaction. Remember? Wood's reaction. So take example here, Rx plus 2La plus XR. In the right, 2Rx plus 2La. This is also you may write in the examination they ask like this also. Remember 2 moles of alkyl halides and 2 moles of sodium. So when they react with each other, they form, of course, okay, this what? LAX. 2 moles. Here the reagent used is triethyl solvent. Understand? So how can you say when alkyl halides are treated with sodium metal in presence of dry ether as a solvent forms higher alkanes. This is the general reaction. You may write here. So when alkyl halides treated with sodium metal in presence of dry ether as a solvent. In presence of dry ether as a solvent forms higher alkanes. Okay? Here, example. So instead of example, you write note. It is this note you cannot be writing the examination. For you, I am writing note. R group must be alkyl group. Alkyls. So R group must be alkyl group like CH3, C2H5, etc. Okay, just ಇದು ನಿಮಗೆ ನೆನಪಿರಲಿ ಅಂತ ಅಷ್ಟೇ. Wood's reaction ಅಂದ್ರೆ because Wood's is different, fitting is different, but the reaction is same. So now you take the example. Anyone alkyl, as I told you, I'll take methyl chloride CH3Cl plus 2Na plus ClCH3. You may take different alkyl halides also. Okay. So then, in presence of a dry ether What is the product formed here? CH3, single bond, CH3 plus, yes, 2 NaCl. Why it is called as higher alkane? I mentioned here higher alkane. Higher means one is more. Here only one carbon atom is there, meth. Here it's also one carbon atom is there, meth. Both are what? Methyl chloride. But the here product formula is what? Ethane. Of course, one carbon atom is more than the reactants. That's why they are called as higher alkanes. Understood? So, how can you write here? When this alkyl ions means methyl chloride. I'm not telling you to take methyl chloride only. The choice of your own. But don't take fluoride. They are not stable. Treated with sodium metal in presence of triether as a solvent forms what? Ethane. Understand? So this is what? Woods reaction. Only alkyl ions. For Fittig, same reaction, but our group must be alkyl. It must be a benzene ring. Understand? For what? Fittig reaction. Reaction, everything is same. Here, R group is replaced by only benzene ring. That is aryl compounds. Understand? Woods Fittig means here two reagents are there, alkyl. One is R group is replaced by CH3, another one is benzene ring. Woods Fittig reaction. Alone Woods, that is only alkyl. Alone Fittig, only aryl. Woods Fittig, one is alkyl, one is aryl. And both the reactions are same. They are reacting with sodium metal and all. Okay, so in the tomorrow's class I will explain Fittig, Woods Fittig and the remaining reactions. Okay, thank you.